In this part we will talk about the priority encoder, but before going to priority encoder, let's see the 4 to 2 binary encoder and how it works. So here is the truth table of 4 to 2 binary encoder, and you can see you have 4 inputs W0 to W3 and 2 outputs Y1 and Y0. So if you see the truth table, so for only for if you see for Y0, so Y0 is 1 when W1 or W3 is high. So that's why it comes to W1 and W3. So it's very simple. So Y0 is equal to W1 or W3. And for Y1 you can see here, so when W2 or W3 is high, so Y1 is high. So this is W2 or W3. So by this you can design a simple 4 to 2 binary decoder, and you can see if W2 is high and W1 is high, in that case what we will get, for W1 we will get 1 over here, and for W2 we will get 1 over here. But in priority encoder the scenario is little bit different. So if the system has highest priority in W3, then it will neglect all the W2, W1 or W0 value, whether it is 1 or 0, it's don't care condition. So in next part actually we will see how priority encoder is working. So you can see that, so when the W2 W0 is high, so we'll get 0 0, and when all the input are 0, so Y1 and Y0 is don't care condition, and we have an extra output which is Z, so to know whether one of the input is high or not. So if all the input is 0, then the Z is 0. So if either input is 1, then it will give you 1, and this is Y0 and Y1. So if Y0, W0 is 1, so we will get 0 0 over here, and if W1 is 1, then we will get 0 1 here. So in priority encoder how it works, if you represent this in a circuit, so it has 4 inputs, 1 2 3 4, and it has 3 outputs actually. So if this is W0 and this is W3, so from the truth table you can see this has the highest priority. So this has the highest priority and this has the lowest priority. So if you go from W0 to W3, so the priority is increasing. Now in the encoder case we see that if both W2 and W1 is high, then we will get 1 in both cases. But if we get a W2 high, then this will be not take as a count. So if we get a W2 high over here, so this is W2 and this is W1. If this pin became high, then we will get only this one. So this is Y1, this is Y0, and this is Z. So Z will be high and we will get 1 0. So that's the main difference from the normal encoder to a priority encoder. And again, if we get 1 in W3, so this will not happen. So then we will get 1 1 in both cases. As you know that if W3 is high, then y1 and y0 both will be 1. So it is clearly seen that in how priority encoder is working here. So if your encoder in your encoder it is written that it's a priority encoder, then you need to know which one is the highest priority, the LSB or the MSB. You need to know that. So if MSB is the highest priority, then if MSB is high, then all the things will be taken as a don't care condition. Now how we can make the circuit out of here? To do that we have to do some K-map over here. So as you see that we have 4 kind of inputs variables, so we need a 16 box, K-map box. Okay, so we have 16 boxes. So now we will consider W3 and W2 in this here, W3, W2, and in this side W1 and W0. Okay, so now it is same like so 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. Now let's put the value over here. So for 0 0 case, so if all the value is 0, we can see this is actually for both. First we will design this K-map is for, as we have 2 output, so we will consider for y1 first. So you can see that for 0 0 the y1 is don't care, so we will put a x over here, so don't care condition. And now for let's check 0 0 0 1. So 0 0 0 1, you can see the y1 is 0 over here. So in this case 0 0 1 1 and 0 0 1 0, if you see that, so this is actually W1. So when W1 is 1, so Y1 is 0. So in both case we can write 0 0 over here. Okay, so now in this part you can see 0 1. So in this situation, so if W is 1, W2 is 1, then you can see that Y1 is 1. So we will not care whether W1 is 1 or W0 is 1 or 0. So we don't need to care. So in these cases, so in this both cases where W2 is 1, so here and here we can write that Y1 will be 1. So in both row we can write that the output Y1 is high. Okay, now let's consider that this one 1 0. So this is the case. So in 1 0, if W3 is 1, then we don't need to care about the W2, W1 or W0. So we can see the output Y1 is 1. So we can easily write over here that whenever W3 is 1, W1 is 1 for all the cases. So this is our actually K-map for Y1. So it is a very simple case. So we have a group of 8 over here, and again we can make a group of 8 with this 8 1. Okay, let's consider this first. So in this case, so we can write it y1 is equal to So for these cases we can see that only W2 is not changing, right? So we can write it W2. Or for this group we can see W3 is not changing, so you can write W3. Okay, so this is our equation for y1. Now we will consider for y2. So again we have to make K-map. So here W3, W2, W1, W0. So 0 0 0 1 1 0, sorry, 1 1 1 0, 0 0 0 1 1 1 1 0. Okay, so for this case now we will consider this one. So again for 0 0 0 this is don't care, and let's see the next one 0 0 0 1. So 0 0 0 1, so this is 0, so we can put it over here 0. And for W1, so if this W1, so this is 1, so in this case, so W1 is 1. So in whenever the W1 is 1, so Y0 is 1. So we can put 1 in these two places. Okay, now we have to check the next one. So 0 1, so 0 1 condition. So in this case you can see that whenever W2 is 1, Y0 is 0. We don't need to take care of this W1 and W0. So whenever this is 1, you can see that, so output is 0. So we can put it 0 over here. Okay, now let's go to the last one, 1 0. So this is 1, so in this case W is 1. Now you can see whenever W3 is 1, Y0 is output. Output is high, so we can put it high over here. Now we can check this condition. This condition is little bit tricky. So for this case you can see, if we consider that W2 is 1, we are getting 0 in this place, but for W3 we are getting 1. So this place has two value, so this has some contradiction in the value. So what we can do, we can check as a don't care condition. So we will erase this one, and we will consider this as a don't care condition. Okay, now we can make the K-map from this group. So here is the group. So group of 8, and there is another group which is these 4 actually. So these 2 and these 2, so this is a group of 4. Okay, so from group 1, from this group, if we see the make the equation, y2 is equal to So in this case you can see that so W2 is changing, so only W3 is not changing, so we can write it W3 over here. And or now we will check this group, these two group. So if you consider this and this, you can see W2 is not changing. So here actually W2 is bar, so W2 bar, and for these two you can see this one and this one, so this is changing, so this one is W1, so we can put it W1 over here, so W1 is not changing in this side. So this is actually our output equation. So y1 is equal to W3 or so W2, and y0 is equal to W3 or W2 bar W1. And we have another which is Z, so Z is equal to W3 or W1, sorry, 2 or W1 or W0. So this is our final 3 equation for a priority encoder. Now if you want to make a circuit from it, so what will be our circuit? So first let's copy this one. So we have W3, and from here we will get 1 actually, so W3 and W2, so it will go to a OR circuit. And this is our actually Y1. Okay, now we have Y0. Okay, we need to do W1. Okay, so we need W3 first. So it will go to a OR circuit. Okay, and then we need these two AND. So we need a inverter over here, and we need W1. So this two will go to a AND circuit, and this will go to the OR. Okay, so this is our Y0. Okay, now we have Z. So we need this or this or this. Okay, so if you see W3 and or W3 or W2 is already here, so we can take one output from here, sorry, input, then another is W1, so W1 is here, and another one is W0, so we have W0 over here. So this 3 input OR goes to Z. So this is our 422 priority encoder. So this is all from the priority encoder. Thank you.